everybody, welcome to the second part of the lesson that was started in the last episode. So in the last episode, we were talking about different kinds of fronts. Today we're going to work on connecting air pressure to the water cycle and to fronts. So again, this is a continuation of the last episode of Shelter in Place Science. So if you are using your note sheet that was in Google Classroom, we're going to finish the bottom of the note paper today. We're going to take a look at air pressure, and then we're going to do another round of you be the meteorologist and you predict what's going to happen with the weather. So let's get going. So if you remember in the last episode, we talked about air masses and the fact that air is moving around, and this air, it's going to collide with each other. And who remembers? What do we call the place where air masses meet? Hopefully you remembered that they meet at a place called fronts. So we looked at 3 different kinds of fronts in the last video, and today we're going to look at how air pressure is related to them. So here is a question I asked in the last episode. I'm going to ask it again. True or false? Fronts can bring nice sunny skies and clear weather. So our cold, warm, and stationary fronts, can they bring nice sunny skies and clear weather? Well, I hope you remember that the answer is most definitely false. Fronts are always going to bring precipitation and clouds. They are not going to be clear skies, because when we have a front, we have air rising. That's going to create clouds, and that's going to create precipitation. So, to refresh our memories from the last lesson, this here is, hopefully looks familiar to you, this is our cold front. So this is where cold air quickly enters an area. It pushes the warm air in the area already up, and as you can see, we definitely get precipitation. Cold fronts aren't going to be short. They're not going to last for days and days, a couple of hours, maybe half a day, and then move on. Our other type of front that we talked about was our warm front, and that's where we've got warm air entering an area. It's going to slide slowly up over the colder air. It's going to produce lots of clouds, and with those lots of clouds is going to come lots of precipitation that's going to last for several days. All right, so now that we've refreshed our memory about what we've learned before, I want you to think about, what do both warm and cold fronts have in common? Well, hopefully remember from just seeing the pictures a moment ago that they both are bad weather, right? They're both going to produce rain and clouds. And hopefully you also noticed they both push warm air up. So if air is rising, ooh, I'm making a connection back to when we were talking about atmosphere and air and wind. And I remember that if air is rising up, that means that they're both going to be low pressure systems. A warm front is a low pressure system. A cold front is a low pressure system, because they both have air that's rising. So let me remind you of what we did back when we were actually in school. So this image should look really, really familiar, because like, remember how I had this image and I called on like 8 different people again and again to review it? Well, here we got our warm air rising, and hopefully you remember that when warm air rises up, that creates an area of low pressure, because the atoms are getting picked up off of the ground. There are less air atoms in the area by the ground, and so that means we have low pressure. And we also learned that another way we can talk about this is by talking about density. Remember density? Density is how tightly packed matter is. It's the amount of mass in a given space. Remember our little smiley faces to represent atoms? So warmer air is less dense because the atoms are moving faster. Those atoms are spread out, and that is what we call low pressure or low density, right? Less atoms in a given place means low pressure or less dense. And on the other side of things, if we have a lot of atoms packed tighter together, that is more dense or high pressure. So although technically, right, what we're learning in this shelter-in-place science is not being tested on. This is something you will be tested on and need to remember, because we definitely learned about density and high and low pressure before we left school. So let's look at this as it relates to our fronts. So here we can see low pressure is formed when we get warm air, represented by the red arrows. That warm air rises. As that air cools and it turns to the blue arrow, we get clouds to form. So when we have a low pressure area, that is going to bring us storms or precipitation. So let's go ahead and fill that in on our note paper. Again, you can access the note paper in Google Classroom. Low pressure systems. Low pressure happens when warm air rises. That should sound familiar from earlier in the unit. Rising air cools and condenses to form clouds, which hold precipitation. So that means cold and warm fronts are low pressure systems. Both cause air to rise and form clouds. Okay, so cold and warm fronts, even though they have slight differences, they are both the same in that they create low pressure. I should also mention here, because students always mention it, they're always like, what about stationary fronts? Well, technically speaking, stationary fronts do sort of fall into this category. However, if we want to be, very strict about the types of pressure, a stationary front does not have as much low pressure because the clouds kind of sit there. They don't have as much precipitation. But if you just want to consider, hey, stationary fronts are also low pressure, you can also consider that too. So low pressure is when we got warm air rising, clouds form. That's going to hold precipitation and make storms. Okay, so this means if a weather forecaster says a low pressure system is moving into San Jose, what kind of weather do we expect? And you often hear them say this when you watch the news or you watch a webcast on the internet. They'll say low pressure system. And low pressure system is code word for what kind of weather. Hopefully you're thinking it's code word for bad weather or rain or snow or sleet or hail. Low pressure system is going to bring precipitation. Here are some just examples of that. We're going to talk in more detail about this later, but you can see here the thunderstorm definitely has tons and tons of warm air rising, and that warm air rising is going to create those giant clouds, thunder clouds called cumulonimbus clouds, and that's going to give thunderstorms their power and their intensity. Another example of how low pressure systems create storms is you can actually get warm and cold fronts to kind of chase each other and start spiraling in on each other. And this is part of how we get the development of cyclones or hurricanes or tornadoes, is a swirling center of low pressure instead of the low pressure just kind of disappearing and moving on. So we'll talk more about things like thunderstorms and cyclones and hurricanes and tornadoes in later lessons. But let's think of something else. I've been talking a lot about precipitation and thunderstorms, but what about a cloud-free day? What about a day like seen here in this picture where there's not a cloud in the sky, there's no rain and no precipitation? What kind of pressure do you think this kind of weather would have? Well, if it's not raining and rain is low pressure, then this must mean high pressure. High pressure happens when we don't have any clouds and we don't have any kind of precipitation. And why is that? Well, think about what high pressure is. High pressure means the air is not rising, the air is actually sinking. So let's go ahead and fill that in on our note paper and take a closer look at that. High pressure happens when cool air sinks. The sinking air prevents clouds from forming, so the weather is clear or no precipitation. Now, a high pressure system doesn't mean the weather is hot or it's warm. You can have a high pressure system in Antarctica Antarctica is still going to be really cold, but high pressure would mean that there's no snow falling from the sky, right? There's no clouds in the sky. So you don't have to be in a warm place to have high pressure. High pressure is anywhere where air is sinking and it prevents clouds from forming. If we take a closer look at that picture here, right, you can see the cold air up in the atmosphere, it sinks down. As it reaches the surface, it does start to warm and move away to other areas, but the bottom line is that creates high pressure. Oh, and another word for this, right? This is a downdraft, an area of air that's sinking, and we know that these arrows here, that's what we call wind, and that's going to blow to another area where that warm air will then rise in an updraft, and oh my goodness, we've got a convection current yet again. So the bottom line here is, if it is sun in the sky and there are no clouds, that's high pressure. If you've got clouds in the sky, you've got precipitation, that's going to be low pressure. And as this picture also clearly shows, you can have clouds and not have precipitation falling. Sometimes it takes several hours, several days for those clouds to fill with enough moisture before there is precipitation. So low pressure is whenever we have cloudy skies, even if it's not actively raining, because remember, the water cycle happens at various speeds depending on where you are on the planet. So low pressure can be just cloudy skies. You don't have to have rain falling down to have low pressure. So that again was a pretty short lesson today because we did most of it in the prior video, but that means we're going to spend some more time doing some guided practice. So we're going to be a meteorologist again. This is where we would normally pull out our whiteboard slates and our whiteboard markers and erasers, but we're going to do this the virtual way. So just like I did in the previous lesson, I'm going to put up the scenario or the question. I'll ask it, kind of talk you through it, give you some hints, and then I will reveal the answer. So if you want to play along, if you happen to have a whiteboard at home, or you just want to write your answers on a piece of paper or pause the video so you have a chance to answer, totally do that so that way you can be testing yourself and making sure you're understanding what Miss Basor is talking about. All right, so let's get going with Be a Meteorologist, Part 2. Okay, let's start with our first situation or our first scenario. A low pressure system is forming over the Pacific Ocean and is expected to come to shore in Santa Cruz in the next hour. Okay, so that's what we know. We've checked the satellites and that's the data we've got. So the question is, what type of weather will the low pressure system bring? Again, we've got a low pressure system over the Pacific Ocean. It's expected to come to shore in Santa Cruz in the next hour. So what type of weather will the low pressure system bring? Remember, you can look back at your notes if you're not sure. And please also notice this question is asking what type of weather. I'm not asking for you to tell me cold front, warm front, or stationary. I want to know what's going to happen in the sky. All right, so hopefully you've had a chance to think of your answer or you've paused the video. If there's a low pressure system, it means we're going to get rainy weather. If you said stormy weather, you're correct. If you said a storm, you're correct. If you said bad weather, you're correct. If you said hail or sleet or snow, I'm going to say maybe. Santa Cruz is generally not cold enough for that to happen, but as long as you're thinking about stormy weather, then you're good. All right, our next situation. The weather report in the newspaper says that a high pressure system is moving in for the weekend. Does anybody even read newspapers anymore? Maybe I should change that to say on the internet. So anyways, the weather report on the internet says that a high pressure system is moving in for the weekend. So your question is this a good time for a barbecue? You're the meteorologist. You're going on TV in 15 minutes to tell your listeners what to do for this weekend. And they want to know, is it a good time for a barbecue? So what's your forecast? If you know that a high pressure system is moving in, what would you recommend to your viewers that they do? So take a moment to figure it out. And hopefully you're gonna get on the newscast and you're gonna tell them that yes, this is an excellent time for a barbecue because high pressure means good weather, it means clear skies, it means your barbecue is not gonna get rained on. And I know I'm gonna bring this up because every year I have a student who asks this. Yes, you could technically barbecue in the rain, right? But most people generally don't find that fun, so we're definitely going to say that a good time for a barbecue is a high pressure system. All right, next scenario, scenario number 3. A warm front is reported for tomorrow. So the first question, and just to let you know, there's going to be 3 questions for the same scenario. The first question is, what kind of pressure system is this? If we've got a warm front, what kind of pressure system? There's a 50-50 chance on this question because there's either high pressure or low pressure. So hopefully you have answered that the pressure is going to be low pressure. And then my follow-up question to that is, well, what kind of weather will we have? So we know it's a warm front. We know it's low pressure. What kind of weather will we have? And remember, you can definitely feel free to look back at your notes, definitely the ones we did today in this video. And if you have them handy from the last episode, you could also look at that too. All right, hopefully you've had a chance to answer this. What kind of weather will we have? Well, we're gonna have rainy weather. You could also say snow or sleet or hail or any kind of stormy weather. And then the last question for this, how long will the rain last? Okay, so this is where you might need to go back to the previous episode because now we're talking about something from the last episode. Remember, we have a warm front. So how long will the rain last if this is a warm front? I also just remembered I reviewed that at the start of this video, so you can also go back to the start of this video to double check. So hopefully you've thought of your answer. The answer here is a warm front is going to last a couple of days. So rainy weather for a couple of days, and that's going to be low pressure. Okay, our next scenario question. First question has a pretty easy 50-50 chance answer. What pressure do cold and warm fronts create? Cold and warm fronts, what kind of pressure do they create? Hopefully you're remembering that they both make air rise and create clouds, so that's going to be low pressure. Now my follow-up question is, why? What happens to make low pressure? Why is it that they are both low pressure systems? And I sort of kind of gave away the answer there a moment ago, but maybe you didn't listen to me. So hopefully you know that the reason they are low pressure is because air rises. And then finally, what pressure does good weather have? Weather that's clear, where there's no clouds in the sky, sunny skies. What kind of pressure does good weather have? Hopefully it's pretty obvious. It's going to be the opposite of low pressure, which is high pressure. All right. Here is a picture of a front. What kind of front is this? You should be able to figure it out. Look at the arrows. Look at kind of the size of the clouds. You can also look at that weather map symbol we talked about in the last lesson. So hopefully you have noticed that there's not a lot of clouds. You've hopefully noticed that the warm air is going pretty much straightly up. So that is a cold front because a cold front comes in quickly with cold air and quickly pushes warm air up. Okay, let's go over our precipitation types, which I did in the first episode of Shelter in Place Science. Let's start with an easy question. What do we call liquid water? Liquid water falling from the sky, what's that called? It's a type of precipitation. We take it for granted. It is rain. Pretty easy one. All right, now from rain, let's go a little deeper. What do we call rain that passes through freezing air? So it definitely falls out of the cloud as liquid water droplets of rain, but then it passes through freezing air, and so that changes what we call it. And rain that passes through freezing air is what we call sleet. All right, our next type of precipitation. It's water vapor that changes to solid before falling. So up in the cloud, water vapor gas changes directly to solid before falling. That is the very unique snow. And then finally, what do we call falling rain that's forced upward to become solid ice? The rain falls down, it gets pushed back up in the cloud by strong updrafts, it freezes into these solid ice pellets, falls to the ground. That is what we call hail. All right, next question here. Ooh, another picture one again. So what is this? I can see the red bumpy line. I can see warm air rising. I can see a bunch of clouds. Hopefully you remembered that this is a warm front. Okay, now we're gonna go over fronts. This is what we did in the last episode. What type of front moves quickly? It's gonna quickly move through an area. I believe the average speed was 22 miles per hour. Remember, you can go look at your note paper if you forgot about this. That is a cold front. What type of front is gonna move slowly? It's still moving along, not that much slower. I think the average speed was 15 miles per hour, but it's definitely slower than the cold front. That is a warm front. What do we got here? I see cold and warm air. I see the arrows showing that they're pressed into each other. I see the bumpy and the jagged pointed blue arrow line connected. I see lots of clouds. What kind of front is this? This is a stationary front because neither of them is going anywhere. They're locked together. So let's do our last question about the water cycle to remember some of those major concepts that are part of fronts and part of air pressure. What process changes a gas, which we call water vapor, into a liquid? This is the process that makes clouds possible, right? So when we've been talking about low pressure systems where clouds are forming, there's a process that changes a gas into a liquid. Hopefully remember that process is called condensation. What process is going to change liquid water into a gas, also known as water vapor? This is really what makes the water cycle get going. It's going to change liquid water into a gas. That is the process called evaporation. All right, and then last but not least, this is not a question that has an actual answer, but what's your pick? What kind of front do you prefer? Are you a cold front kind of person? Warm front? Stationary front? What is your preferred kind of bad stormy weather? If we're gonna have stormy weather, what do you prefer? A cold front, a warm front, or a stationary front? And then most importantly, why? Tell me why. This will be one of the questions in the self-quiz, so you can kind of provide me your reason why so I can get a feel for what kind of weather you like, what kind of stormy weather person are you. All right, so that's it for today's lesson. As you just heard there in the background, some beeps of the Google Hangout that I had open. I'm hoping to set up some video Google Meets and Google Hangouts over the next couple of days to check in with you guys. So have a good one. I'll see you in the next episode. Bye.